Hi. So recently I just, I don't know why, but I got curious about the WebSocket protocol, and so I rewrote a server for it in C, which you can see here in my on my GitHub. It's CCWS, and yeah, it's pretty much what you expect. You can create a server, receive messages, send messages, destroy the server, these kinds of things. And so, well, I thought that doing a full video, like implementing the thing in C, might be way too long. So instead, I'm just gonna do a little presentation on how the protocol works, why it exists, and like there is a lot of little quirks about it, which I think are a bit interesting. So if you're even if you don't know anything about C or on my channel, I think it's pretty interesting to understand how it works under the hood, so that yeah, maybe you can know when to use it and when not to use it. So what was the initial problem that WebSockets were trying to solve is that HTTP is only request response. And so what happens when you want to have any kind of live interaction? Would it be like your website has, I don't know, a dynamic graph, a dynamic plot, I mean, that receives live, I don't know, data from the stock market, or it's a chat, or it's I don't know, a little video game in the browser and so on. And so basically for a long time they tried all kind of tricks. So there was polling, so you just retry the request every X amount of time to know if there is some new information. Long polling, which is the same thing, but you leave the connection open until there is an event. And there's a thing that I didn't know about, which is server-side events. And apparently it can solve a lot of things, but it's only unidirectional, so it's only from the server to the client. And yeah, obviously, if you have some kind of, for example, a chat application, it's nicer to have like this bidirectional pipe between the client and the server. So that's what WebSockets were created for. So the WebSockets, it's a bit weird. It starts with a handshake, and this handshake is actually yeah, HTTP. So this is how you open a WebSocket connection. You send a GET request to some place, so some WebSocket server, and you can see there is already some, there is something that you would expect. For example, upgrade is WebSocket, connection is equal to upgrade, that kind of makes sense. But then there is this weird key thing, and well, the version is also normal, but I will explain the key at the end, but it's a bit tricky. And the reason why it uses HTTP is because yeah, the protocol was built to be backward compatible with the whole internet, you know, so that yeah, yeah, it can be actually used. And so yeah, and the server will respond back with a switching protocols response, like so, and it should do something with this key that indicates that it understands the thing. And after that, this is only a regular TCP connection. There is no more HTTP involved at all. And so those TCP now the two servers, well, the two computers will communicate via TCP, and so they will exchange frames, and a frame as a header, which you can see here. So there is a at the start there is a couple of flags, then there is an opcode, which is just like the type of the message. Then there is a mask, which I will explain after, and then there is just the payload length, and they have this a bit strange thing where if the payload length is less than 127, it will be only in 1 byte, and if it's more than that, it will be in 3 bytes or 4 bytes, and if it's even more than that, it will be in 8 bytes. Basically, just trying to reduce the amount of data that they use as much as possible. Then you have the masking key, which is present if there is a mask, and then you finally have the data. The data can be anything. And so, yeah, this is, well, I will explain later this one. So the message types are, the most common one would be text, which can only be UTF-8. There is a binary, which, well, can be any kind of binary data. There is a close message, which can be sent by either endpoint to close the connection, and the other endpoint should respond with another close message and then shut off everything. And then there is a basic heartbeat system that is built into the protocol, which is a ping pong. And so whenever a guy sends a ping, the other guy needs to respond with a pong, and then you can set up your server and your client with a certain heart beating interval, and if it fails, I don't know, restart the connection or something like that. And there is this continuation type, which is for I don't know, multi-frame messages, let's say. So you can have what you receive if you probably used WebSockets before. What you receive in the end when you do like a receive is that you get a full message. But this message on the wire can be split into multiple frames to help with to avoid maybe like having the server or the client allocate the full memory of the message it wants to send or something like that. So yeah, that's fragmentation. So the way it works, that's just what I explained, is that you can have a message that is fragmented in multiple frames. And so the way it works is that for the first until the last one, the final bit is set to 0, and then when the final bit is set to 1, so the final bit is this guy, the first one. So as soon as the final bit is set to 1, you will know that it's the end of your message. And so the first frame should contain the opcode, so the message kind, so which can only be text or binary. And then the other frames will contain the opcode continue to indicate that there should be a next frame after that. There is one extension. Well, there is multiple extensions, but I think there is only one that is actually currently stable. So, and this extension is the per message deflate extension, which allows, well, it's similar how you can compress your HTTP request and response with gzip, usually. Here you can compress your messages with deflate, the deflate algorithm. And so, yeah, you just, to enable that, you just have this sec WebSocket extensions, where you say, I want to use this this extension, and then you can set some stuff about how the compression is handled. And again, this is something if you have like, if you use a library for a WebSocket client or a WebSocket server, you can usually set those up to something that is, I don't know, that makes sense for your application. So if you're transmitting a lot of big JSONs over this connection, you may want to use this, but if it's only very small message, it's probably not worth it to pay the cost of compressing and decompressing your message. Yeah, I mean, they use this flag to indicate that there is compression or not on a frame. So yeah. Then there is the WSS, which is just the secure version of the WebSocket protocol. And it's basically exactly the same protocol, but you wrap it in TLS. So yeah, that's it. And it works the same as HTTP. So yeah, to come back to the very start of the presentation, I showed you that there was this weird WebSocket key and WebSocket accept headers, fields, I should say. And so the reason why this exists is that there was how do you say, a proof of concept or something like that, a draft of the WebSocket protocol that was proposed, and then some guy made a paper that it was susceptible to an attack for caches, like HTTP proxies that do not understand the WebSocket protocol. And so they had to add two mechanisms. One of them is this UID. So there is a fixed UID for the WebSocket protocol. Basically, I don't know. It's a bit weird to explain, but basically, like the client is gonna send this, and then the server is gonna have to do some concatenation with a fixed UUID and then SHA the whole thing. And this whole thing exists just to prove that the server where we're sending this to actually understands the WebSocket protocol, because the exploit apparently was for something that didn't, like, if a proxy doesn't understand the WebSocket protocol, it was, I don't know, an attacker was able to do some things, and so they had to come up with this strange mechanism. The other thing is the masking, which I mentioned earlier. This is also, I don't know, for this proxy attack thing, where, yeah, I forgot how it works because I made this presentation a week ago. But as far as I understood it, it could be that, like, an attacker sends a WebSocket message that looks like an HTTP request, and so it would be able to change some fields in that proxy. And so the way this works is that now that you have masking, you just have a masking key, and then all of the bytes of the message are XORed with this key. And so this makes, basically this just jumbles up the bytes in every single one of your message. And so this way, like a proxy that is unaware of WebSockets cannot consider this a valid HTTP request. So yeah, that the end was hard to explain, but I hope you got the gist of it. And yeah, the main point of this was anyway to maybe just either get you interested and write your own WebSocket thing, or yeah, next time you use the WebSockets, you understand a bit better how they work and like the downsides and upsides of them. So anyway, that's all I've got, and I'll see you in the next one.